question number 4 gives us a graph where scientists have collected data on human births, and they're looking at the mass of each baby at birth and whether they needed to be transferred to a special care baby unit. So we can see that mass of birth is along the bottom, and we've got our extremes of mass birth where we have quite a low population frequency, and then as we get into the average mass of birth, then we get a much higher population frequency. We can see that our transfer to special care unit is much higher when the mass at birth is very low or very high. When it is within the average mass at birth, then it's a much lower transfer to the special care unit. So the question asks us to use figure 5, so we should be using data and numbers from this graph to explain how human mass at birth is affected by stabilising selection. So stabilising selection tends to favour the average, it doesn't favour the extremes of the phenotype. So therefore we need to identify which babies are being transferred to the special care unit. So those that are under 2,800 or those that are over 4,200 are much more likely to be transferred to a special care baby unit. They will allow a range for these figures, so if you say any value between 1,400 and 2,800, that's acceptable for the lower weight, and for the higher weight, anything between 4,200 and 5,200. They will also accept the converse, so instead of saying which ones are more likely to be transferred to a baby unit, you can talk about the mass values that are least likely to be transferred, which are the values between 2,800 and 4,200. So therefore, the values that are more likely to be transferred to the baby unit, so the higher and lower extremes, means that these babies are much less likely to survive, to reproduce, and so therefore they're less likely to pass on the alleles that they carry for the extreme mass at birth. Therefore, the extreme mass at birth decreases in frequency in the population, or the allele for the extreme mass at birth decreases in frequency. They will accept proportion or percentage for frequency, but they will not accept number for frequency. If you do give the converse to the answer, then they would be looking for the fact that those that are between the mass at birth of 2,800 and 4,200 are less likely to be transferred to the baby unit. Therefore, they are more likely to survive and reproduce, so they are more likely to pass on their alleles. So therefore, the allele for the average or the mean mass at birth is more likely to increase in frequency in the population.